Hey, welcome to your favorite intermediate algebra class. It's good to see you. We're going to talk about some absolute value functions again. And more specifically, we're going to graph some absolute value functions, do some transformations with those, some rigid transformations, okay? So let's look at the old definition you notice there. The absolute value of x is a piecewise defined function. And so what if we were to graph y equals the absolute value of x? And you say, well, I could do the old table of values, plug some points in, right? And I know, well, let's do 0, 1, 2, 3. How about -1, -2, -3? And you plug those in, and you say, well, absolute value of 0 is 0. Let's plug 1 in for x. Absolute value of 1 is 1. Absolute value of 2 is 2. Absolute value of 3 is 3. Plug in some negative numbers now. Let's plug in -1 for x. Absolute value of -1 is 1. Absolute value of -2, of course, is 2. And so on, right? Okay, so we got these points here. We look at this graph, 0, 0, 1, 1, 2, comma 2, over 3, up 3, 3, comma 3. We're like, okay, I can see that. It's going to be a straight line there. -1, comma 1, -2, comma 2, and -3, comma 3, and so on. And you can see that side. So that V graph is the parent function, the absolute value of x. Okay, so anything um, that anything maybe that involves an absolute value is some kind of transformation of this blue graph right there. Okay, so for instance, this absolute value of x minus 3, the absolute value of x minus 3, the question is, what does that do right there? That minus 3. Well, let's take a look at it. Let's plug some points in. Let's plug in 0. You say, well, the absolute value of 0 is 0. 0 minus 3 is -3. Plug 1 in. Absolute value of 1 is 1. 1 minus 3 is -2. Plug in 2. Absolute value 2. 2 minus 3, -1. 3. Absolute value 3. 3 minus 3 is 0. Okay, let's go to the left now. Absolute value of -1. 1 minus 3, -2, right? Plug in -2, absolute value -2, 2. 2 minus 3, -1. Absolute value -3, 3. 3 minus 3, 0. You notice that these, well, let's take a look at it first. 0, comma 3. Whoops, I said I didn't. 0, -3. Sorry about that. 0, -3 right there. Didn't label that correctly. 0, -3. Okay, so I got the point 0, -3, 1, -2, 2, -1, 3, comma 0. Okay, you kind of see that there. Let's go to the left now. -1, -2, -2, comma -1, -3, comma 0. So you're like, oh, that looks exactly the same as the old blue function did, right? Exactly the same as this, except what? It's down 3 units. That vertex point went down. This is your vertex, oftentimes referred as the point HK. We'll talk about that in a minute. It all of a sudden was brought from 0, 0 down to 0, -3. So what does this piece do right there? We call that a vertical shift down 3. Okay, so if you have something outside of that absolute value, like the -3, it's going to move it down 3. Now, let me do another one. Let's say you had a different function. G of x is the absolute value of x except plus 2. You say, well, that's going to look the exact same as the V, the blue one, except it's up 2. Up 2. So they draw that very good, but anyways, that's up 2. Okay, rigid vertical shift up 2. Okay. Now, what about if we put it inside that absolute value, with that absolute value of x minus 2 in this case? What would that look like? Let's throw some points in. How about 0? 0 minus 2, absolute value of -2 is 2. 1, 1 minus 2, Negative 1, absolute value of negative 1 is 1. 2 minus 2 is 0, absolute value is 0, 0. 3 minus 2 is 1, absolute value of 1 is 1. 4 minus 2 is 2, absolute value of 2 is 2. 5 minus 2 is 3, absolute value of 3 is 3, and so on. Let's see if this is enough to kind of see the V here. 0, 2, 1, comma 1, 2, comma 0, 3, comma 1, 4, comma 2, 5, comma 3. You know, we could go negative 1. Negative 1 minus 2 is a negative 3, but the absolute value of negative 3 is 3. Negative 1, 3. And anyways, you can kind of see, oh, there it is. There it is. So how did that compare to the original parent function? Oh, you say, well, it just moved that point over 1, 2 spots, right? So this, if it's inside like that, absolute value of x minus 2 there, this is a horizontal shift right 2 units. And you know, that's kind of interesting, but so it's kind of counterintuitive. You would think that x minus 2, you would think it would go to the left, but it actually goes to the right because it requires a positive value to create a 0 inside of there, positive 2, if you will. Okay. So if you had, let's say you had a different function, like, extend this a little bit here. How about y equals absolute value of x plus 4? So instead of a minus, you have a plus, plus something. Well, this is going to be a horizontal shift left 4, right? And if you're not sure, you plug some points in. So it's going to look like this. Okay, look exactly like the blue, except it's left 4. That's a horizontal shift left 4. Okay. All right. You know what? Let me go back to this. What about if we did a couple different things here? What if I went plus 7 minus 2? Then here you would say, oh, that's a horizontal shift, right or left. You say, well, that's got to be left because it's a plus inside there. Left 7, and this is down 2. Vertical shift down 2. So left 7, down 2 is where that vertex is, so it looks just like that. And of course you could plug some points in and you could check it as well. All right, what if there's a negative in front of the absolute value? What would that do? Well, I'm not sure. Let's check it out. Let's plug some points in. 0, 0, 1. Take the absolute value of the 1 first, and it's 1, and then you apply the negative. Negative 1. 2, plug the, take the absolute value of 2, which is 2, and then you apply the negative out front, so negative 2. 3 is going to spit out negative 3. Let's do negative 1, negative 2, negative 3 now. So now, let me erase these. Plug in negative 1, take the absolute value of the negative 1, which is 1. Then you apply the negative out front, so you get negative 1. Absolute value of negative 2 is 2. Then you apply the negative out front, negative 2, and so on. Okay, so we put these on our graph. 0, 0, 1, negative 1, 2, comma, negative 2, 3, comma, negative 3, and so on. Negative 1, negative 1, negative 2, negative 2, negative 3, negative 3. And you can draw that. And you're like, oh, wait a minute. That looks a lot like my original. Here was my original, except what? Instead of 1, 1, it's down here. 1, negative 1. Instead of 2, 2, it's down here at 2, negative 2. So it flipped that thing over. Okay, so flip the V over, and what we call that is a reflection about the x axis. Okay, this is the x-axis. You know, it took every point, like this 3, 3, and it flipped it over down to here, 3, negative 3. Flipped it over, reflected it about the x-axis, okay? All right, last one. Let me test you here. What would this absolute value of x plus 4, what would that do? Right or left? And you say, oh, that's a horizontal shift. If it's a plus in there, you say that's a left 4. And then is that up or down? Well, the vertical shift is intuitive. If it is plus, it's actually up. Okay, so horizontal is kind of counterintuitive. Again, if it's a plus in there, it's a left. If it would have been a minus 4, that would have been right. Okay, and then we could graph that. All right, let's move on here. So kind of to summarize here, the absolute value of, or a, y equals a, absolute value of x minus kh has the following characteristics. So your hk right there, if you can identify your hk, that's your vertex, right? That's at the tip of that point there. And it's V-shaped, opens up if A is positive. So if A is positive, it opens up there. And of course it's down if A is negative, okay? And then if the A value, so if the absolute value of that of A is less than 1, it's wider. Another way to say that is a vertical shrink is another way of saying that it's wider. Wider is kind of layman's terms. Now, if the absolute value of A is bigger than 1, okay, that is a vertical stretch. So it becomes narrower, if you will, narrower, okay? So let me give you an example of that right here. Okay, first of all, we know that's going to move it left, 1. That's going to move it down, 2. But what's the 2 going to do is the question, right? I say, well, is that 2 there? That's my A value. Is it bigger than 1? Is the absolute value of the number bigger than 1? So I take the absolute value of 2, it's 2. Is that bigger than 1 or is it less than 1? I say, oh, well, it's bigger than 1. So that is what's called a vertical stretch. In other words, it's narrower. Narrower. Okay, so let's take a look at some points here. Equals, oops. Okay, so we are left 1, and down 2. So can you see how your HK, let me rewrite this again. You see how your vertex is going to be, h is, now you got to be careful on that, it's x minus h. So let me rewrite that as x minus negative 1 minus 2. Can you see how h is actually negative 1? It's left 1, and then your k, you see how that's going to be down 2? Your k is negative 2. So negative 1, negative 2, that's your vertex right there. And you can pull it out of the equation if you'd like as well. Okay, but I like to think about it in terms of the transformation. Okay, there's our vertex. So when I'm plugging some points in to this equation, let me erase this for a minute. I'm going to pick negative 1 because I'm left 1, and I'm going to keep going. Let me go to the right a couple, 0, 1, and then let me go to the left of the vertex. Again, this is my vertex. Let me go to the left of the vertex. So an x value of negative 1 is my vertex. So I'm going to go to the left now, negative 2, negative 3, at least a couple to the left. Okay? And I plug it in one by one. All right, negative 1 goes in. And I know we already know the vertex, but I'm just showing you that we can plug it in and find the k value if we want as well. Okay, There's our -2. -1. Plugged in -1 for x, spit out -2. I already knew that that was the V spot, right? Plug in 0 now. Plug in 0. Let me erase this. 0. I get 0. Okay. Plug in 1. 1 plus 1, 2. Absolute value 2, 2. 2 times 2, 4. 4 minus 2, 2. Right? I just plug them in one by one. Plug in -2 now. So I get -2 for x. -2 plus 1 is a -1. Absolute value of a -1 is a 1. So I got 2 times 1 minus 2, which is, guess what? 0. Plug in -3. -3 plus 1, -2. Absolute value of 2 is 2. Absolute value of -2, sorry, is 2. 2 times 2, 4. 4 minus 2, 2. Okay, so we got these points here. 0, 0, 1, 2. There's my right-hand side. I got the -2, comma 0, -3, comma 2. There's my left-hand side. Now remember, the original looked more like this. You see how the blue one is a little steeper? It's a little narrower. That's because of the 2 right there. Okay, if that number, if the absolute value of that number is bigger than 1, it's narrower. It's a vertical stretch, we call that. It's a vertical stretch. If it would have been something like this, let's say a half, and then this same stuff, okay, you could have plotted some points, but you would have seen something like this instead, a little wider, if you will, okay, because that number is less than 1, greater than 0, the absolute value of that number. Okay, last spot here, write an equation for the graph shown. Now, you notice you had the vertex. That's nice. You say, oh, that's my HK. And then you got this other point, 5, -1. So some random XY point on this graph. So what I'm thinking is, let me write this general form here. And let me plug in HK, X, and Y. So first of all, Y is -1. A, I don't know. This is what I'm doing is I'm solving for A. Okay, I'm solving for A. What's my X value? 5 minus what was my H2? What was my K1? Take the absolute value of 3, which is 3. So I got 3A plus 1, subtract 1, -2 equals 3A. Looks like A must be -2/3. Good, now I can write it. So I know I need my A to write an equation. And I also need my vertex, my HK. These are my two things I need to write for the absolute value. And my vertex here was 2, 1. So now I can write this equation. Plug in A, plug in H, plug in K. There's the equation of that graph. All right, see you guys soon.